Okay, so let's solve simple neural network exercises. Okay. So for the following network, calculate the net input to the neurons. Okay, first problem. For the following network, shown, find the calculate the net input to the output neuron. Calculate the next net input to the output neuron. Okay, so let's say the neural network looks like this. X1, X2, X3. So this is the input layer. Okay, so this is input layer. For neuron X1, let's say I have the value for 0.3, for neuron X2 0.5, for neuron X3 let's say the value is 0.6. 1 second. And it's a single layer neural net. So let's say the output node is Y. Okay. And output node is Y, and then final output is small y, let's say. And the weight given (0.2), 0.1, and let's say this is minus 0.3. This is the scenario we have. Now what is the net input to the output neuron? That means you have to find the Y in, if you remember. Y underscore in, let's say. Then what is the output input here in this? So this is a simplistic thing. We are not even considering the activation function over here. Simply we are considering in this problem, which is a simple neural network problem, we are simply considering the weight of the connections, which is considered as signal, and the input. Okay. So if you write it, the given neural network consists of 3 input neurons and 1 output neurons. Okay, the inputs are and the weights are, let's write it in a matrix format: x1, x2, x3, 3, 5, 6, 3, this one, 0.5, 0.6, 0.3, 0.5, 0.6 is the input matrix. So we can write it 0.3, 0.5, 0.6. Okay. And this is W1, this is W2, and this is W3. Okay. So weight matrix we can write. This is just a representation, nothing else. Don't think that no anything else. This is just a representation. W1, W2, and W3. Okay. And this is nothing but 0.2, 0.1, and the last one is minus 0.3. That's all. Now, therefore, the net input can be calculated as y underscore in equal to summation I equal to 1, 2, 3, because you have 3 input only, which is nothing but xi wi, which you can write as x1 w1, x2 w2, and x3 w3. Okay, and then this calculation would be nothing but value of x1 is 0.3 into multiplied by 0.2 plus x2 value is 0.5 into 0.1 plus x3 value is 0.6 into minus 0.3, and altogether it comes around 0.07 minus 0.07, because this is nothing but 0.5, 0.06, this is point whatever, so it comes around minus 0.06. Okay. So this is the net input of this y in. Okay, so here this input has come. That's all. This is a basic neural network things that we have calculated, and we haven't bothered about the bias in this problem, neither we have bothered about the activation functions. Okay, simple calculations like without activation function how things happen. Okay, I hope you understood this thing. Let us take another problem. So next, question number 2. Calculate the net input, same thing. Calculate the net input for the below network. For the below network with bias induced in the network. With bias induced in the network. Let's say how the things are. So in this case, Let's first draw the network. Let me draw it in a more lucrative way, the yellow color. X1, X2, same way it is connected to the output layer, output neuron, which is capital Y, and the actual output is small y. Okay, here it is, input is 0.2, input for X2 is 0.6, and the weight here W1 is nothing but, let's say, 0.3, and weight here in W2, let's say 0.7, and here we have a bias and output neuron, which is the bias input is 1 and bias weight is 0.45. Okay. This is the situation we have. Now what is the net input? Okay, so again, if you write it, inputs are (0.2, 0.6), and the weights are 0.3, 0.7. Okay, and since the bias is included, B equal to 0.45, and the bias input, we can consider it as X0 is equal to 1. The net input is calculated as Y underscore in equal to, because this is B into 1, this is bias, okay, B into 1, this one, not this one. Okay, so the formula says that B plus summation I goes to 1 to N, this is I, Wi Xi. Now here one catch is that we are including bias here, B. Okay, till now we haven't used any activation function, no activation function until now. Okay, no activation function until now, no activation function we have used. Okay, so this is B. B is 1 into 0.45 is nothing but 0.45 plus, again same thing, X1 W1 plus X2 W2, which is nothing but 0.45 plus X1 W1 is 0.2 into 0.3 plus 0.6 into 0.7, and altogether it comes around 0.93. This is the net input. Just that we have considered here bias. Okay. Fine. Okay, now this is there. Now if we consider the same thing with activation function, then in the question number 3. But before that, I will be happy if we can solve 2 questions. Question number next to question number 3. Solve it. First, a simple neural network. Calculate the net input for the following network. Zero point 0.1 0.2 0.3. Let's say weights are 0.2, 0.1, 0.5. This is y, small y. So what is the y in here? Net input. Calculate it. So it's very easy. All of you please calculate. So in this case what will happen? So this is x1, x2, x3. So as usual, y underscore in equal to xi wy. I goes to 1 to n. Okay. It is as simple as that. 0.1 into 0.2 plus 0.2 to 0.1 plus 0.3 to 0.5. Okay. So how much it comes? Yes, many of you are Yeah, 0.19. Yeah. This is the net input. Now in this problem, just add a bias here. Let us keep it simple. So just that, if it is so what will the formula will change a little bit. It will be b plus I equal to 1 to n sin wy. So this b is nothing but 1 into 0.2, which is 0.2 plus this whole thing 0.19. So I think 0.39. Okay. So this is how to calculate the net input for a simple neural net. First, considering without activation function and without bias, and secondly considering the bias only. Next we are going to see how to do the same thing with activation functions involved.